Hey everybody, welcome back to a new video. Today we are looking at a brand new battery from PowerQueen. This is their 12 volt 200 amp hour battery. Now I have reviewed a 200 amp hour battery from them previously on the channel, but this one is slightly different. This one has low temperature charging protection, and it also has internal heaters. So this can be used from -4 degrees Fahrenheit all the way up to 140 degrees. So you have a much wider operating temperature on this battery, and it's really designed for cold environments. So if you are using your batteries in a cold environment, whether you're in a cabin or in an RV that you're using year round, this would be an excellent option. Now, as for the actual technical specifications on this is a lithium iron phosphate battery rated at 4,000 cycles to 80% of the original capacity. This is a 12.8 volt nominal battery with 200 amp hours of capacity, or right around 2,560 watt hours. Now this does have a 100 amp BMS in it, so it supports a continuous output of 1,280 watts, and it can also charge at 100 amps. So just keep in mind, this is a big battery with a smaller BMS. Now this battery comes in at 44 pounds, and it does have the handles on the side to carry it around. For the dimensions, it is 21 inches wide, 8.5 inches tall, and 8.2 inches deep. Now if you happen to have a higher voltage inverter, like a 24 volt inverter or a 48 volt inverter, this does support series connections, so it will work with those. You'll just have to connect 2 of them together in series for a 24 volt system, or 4 of them together in series for a 48 volt system. Now this also has the ability to be connected together in parallel, so you can put 16 of these together for a huge backup system of 40 kilowatt hours of capacity. Now the MSRP for this battery comes in at $999. It often goes on sale on their website, and at that $999 price, this is right around 39 cents a watt hour. Now PowerQueen also offers a 5-year warranty for this battery, and you can view the warranty details on their website. Well, now that I've covered all the specifications for this battery, let's go ahead and jump into the actual testing that I did, which is way more important. The first test I did was a full capacity test, so I charged this up to 100%, connected up my AC inverter with a shunt on the negative line, so I could track all the power coming out of this. So I started the load, which was at 0.2C rate, right around 512 watts, and I let this go all the way until it shut off, and I was able to pull a total of 202 amp hours, or right around 2,570 watt hours. So we were able to get rated capacity on this battery. Now this battery has a 100 amp BMS inside, so I always like to see if it can handle 100 amps continuous. So I connected up a 107 amp load, pulling right around 1,350 watts. So I was kind of overdrawing power on this just to see if there were any issues, and I set a timer, and after 10 minutes it was doing just fine at that 107 amp level. So in fact, you can pull a little bit over 100 amps without any problems, so this does support its rated max output. Now the next testing that I wanted to do on this battery was to confirm that it could handle the full 100 amps input. So I have a couple different chargers that I'd have to put in combination to get to that 100 amps. Now the first charger I used was this PowerQueen 20 amp charger. This is super easy to use. It's plug and play. You plug it into the wall and then take these alligator clamps and connect them up to the terminals. And when I was using this charger, I was getting around 19.8 amps output, so very close to its rated output. Now I wanted to combine this with another charger. I have this Ames power converter, which goes up to 75 amps. Now when I plugged that in, I was getting 75 amps on that and 20 amps on this, so we were getting 95 amps input on this battery, which was really close to the maximum rated input. So this can handle at least 95 amps input. I didn't have any other chargers that would get closer to the 100 amp max. Now in a future video, I want to talk about the basics of charging these batteries. I get a ton of questions about which charger I should purchase for a battery like this. There are many different options, but this one's a great option for a plug and play wall charger. 20 amps input, this is on their website. I'll include a link to this down in the video description. You also have solar charge controllers. Like I said, I'm going to do a future video that will cover charging on these larger batteries. So you can charge with your vehicle, you can charge with solar, or you can charge with AC power. Now so far, this has actually done really well in my testing. It's standing up to all of its advertising claims. Now in order to move forward, we're gonna have to do a teardown so we can see the internal build quality. We can test the low temperature charging protection, and we can test the actual internal heaters. So let's go ahead and jump into the teardown. Now I never recommend that you guys tear these apart. The top is completely glued on, so it's gonna be fairly difficult to remove. Let's go ahead and jump into it. Okay guys, I think I got it after wrestling it for quite a while. It's finally breaking the seal here. Okay, so I want to show you guys the main positive and negative connections before I take this out of here. So these are two 8-gauge wires in parallel. You have 2 for the positive, 2 for the negative, and these are silicone and they are rated for 200C, so they can definitely handle the heat. Looks like these are actually glued in with lock washers as well, so very secure connections on the main positive and negative. Let's go ahead and see if we can get this out. Okay, so we finally got this out. It took a ton of wrestling. You can see all the glue at the bottom. So this is the bottom of the battery. This is the top of the battery. Now, looking at the cells, there are 8 cells here. This is a 4S 2P configuration. So you have 4 sets of cells in series, and then each of the modules are 2 100 amp hour batteries wired together in parallel. So that gives you a 4S battery with 200 amp hours of capacity. Now, the main terminals of all the batteries are laser welded together. That's really durable. You're not going to see those coming apart. And the balance leads are screwed down and glued down, so very good there. You're not going to see any issues with that. And then you actually have 4 battery temperature sensors, so that will tell you when the battery is in a freezing state. Now, this battery does have heaters on it to keep it warm in the winter. You have a large heater on the bottom. This is the orange plate, and then you have a large heater on the top. Now, you do have fiberboard to protect the heaters and the side of the battery. So you have fiberboard here, and you have fiberboard between each of the cells here so they can't rub together. And then you have these compression straps that go along the entire battery to hold everything together. So everything looks good on the build quality. Now, these cells do appear to be EVE cells, which are high quality grade A cells, and they do appear to be new. And they are rated at 320 watt hours, which is 100 amp hours per each of these cells. So everything looks good there too. Now, I've gone ahead and turned the battery facing upward. So this is how it sits in the case. You have the BMS on top. Now, the BMS, or the battery management system, does a lot of different things. It has a lot of protections in here. Now, it senses all the voltages of these cells and tells basically the battery when to stop charging and when to start charging. It also has these low temperature sensors because you do not want to charge lithium iron phosphate below freezing. It will stop that charging if these sensors are working. So it's good to see a good BMS in a battery like this. Now, the connections are glued in there, so they're not going to come out. Let's go ahead and start doing some testing on this to see if we can get this to shut off when it's cold and to see if we can get the heaters to turn on. Okay guys, now I want to go ahead and move forward with testing the actual heating pads and the low temperature charging protection on this battery. So the way I'm testing is going to be very similar to the YouTube channel Lithium Solar. He came up with this testing method and it was basically genius, so I'm going to be using the same method. So I have my DC power supply charging the battery at 9 amps, and I have my clamp meter over here showing 9 amps going into the battery. So what we're going to do is we're going to simulate the battery going under a freezing condition by taking these temperature sensors and putting them into the ice water. So go ahead and do that. Okay, so really quick, you can see it's no longer charging, but we have 6 amps still going into the battery, or at least going into the heating pads. So 6 amps into the top and bottom heating pad, and that is going to heat up the battery. And when these temperature sensors basically sense that it is above freezing, it will begin to charge again. So if I warm these up with my hand, you can see now we are charging at 9 amps again. So it does appear to be working, both the low temperature charging protection and the heaters themselves. Now, just FYI, I initially did my testing with these 2 battery temperature sensors over here, and it worked just fine. But I just tried with these 2 here, and they do not appear to be active. So it looks like you only have 2 battery temperature sensors that are active, and you have 2 that aren't active. Now, as I was putting this back into the case itself, I failed to mention that none of the batteries are bulging, and they're very compacted together. And this also has a thermal switch here that basically shuts off the BMS and the battery if things get too hot. So it does have a high temperature switch as well. Let's go ahead and get this thing back into the case. Okay, so what do you guys think of that teardown? Now, that was pretty cool. I was able to get the top of the battery off without damaging it. And it just shows you that you don't have to take a saw and chop the whole top off and completely ruin the battery. As long as you're careful, you can get to the insides. Now, what were my actual thoughts of this battery and its performance? Well, we were able to hit advertised output, capacity, charging input, low temperature charging protection, basically the heaters, all that worked as advertised. So definitely a great battery for low temperature climates. I would not recommend just going out and purchasing this battery with the extra features if you're going to be in a warm environment or you're not going to use it all year round. So PowerQueen does make a 200 amp hour battery that's slightly different than this one. The form factor is a little bit wider and shorter. And that battery, interestingly enough, has a 200 amp BMS in it. So you can actually connect up one of those batteries to a 2000 watt inverter just fine. So I guess that's the only downside to this battery, is it has a 100 amp BMS in it. The cells inside can definitely handle the full 200 amps. There's 8 cells in there, 2 of them in parallel, and then 4S configuration should be able to handle 200 amps without a problem. So one downside to the battery, not a 200 amp BMS inside. But if you want something that's not so expensive and that works really well, they have the other 200 amp version with a 200 amp BMS. Anyway, guys, thank you so much for watching the video today. Please give me a thumbs up if you liked the content, and hopefully we'll see you guys in the next video.